What if the ultimate speed limit of the universe could be broken? What if you could travel faster than light? Not just a little faster, but fast enough to cross galaxies in moments. To reach distant stars within a single lifetime. To explore the very edge of the universe and come back. It sounds impossible, because according to everything we know, it is. But what if the answer isn't about breaking the rules, but bending them? Before we dive in, if you want to keep exploring the most fascinating and mind-bending truths about space, make sure to subscribe, like, and stay with us, because here we don't just explain the universe, we experience it. Now, let's go beyond the limit. In our last video, we explored the speed of light, the fastest speed anything can travel. Nothing with mass can reach it. Nothing can go beyond it. It's the ultimate cosmic speed limit. But that hasn't stopped scientists from asking a dangerous question. What if there's another way? You see, there's a loophole hidden deep within the laws of physics. And it begins with a simple idea. What if you don't move through space, but move space itself? This is the concept behind something called a warp drive. Instead of accelerating a spacecraft to incredible speeds, a warp drive would bend space around it, compressing space in front of the ship and expanding space behind it. So the ship itself never breaks the speed of light, but the distance between where it starts and where it ends shrinks. Imagine standing on a long carpet. If you want to reach the other side, you could walk across it, or you could pull the carpet toward you. That's warp travel. You're not moving faster. The space is moving for you. This idea was first described by physicist Miguel Alcubierre in 1994. And on paper, it works. The equations of Einstein's relativity actually allow it. But there's a catch, a very big one. To create this warp bubble, you would need something called negative energy. Not just a little, but enormous amounts. More energy than entire stars produce. And negative energy isn't something we can just create. It's theoretical. We've observed tiny quantum effects that hint it might exist, but nothing close to what we would need. Still, the idea hasn't been abandoned. Scientists continue to explore whether smaller, more realistic warp bubbles could exist, and some recent studies suggest it might not be completely impossible. But warp drives aren't the only idea. There's another, even stranger possibility: wormholes. A wormhole is like a shortcut through space and time. Imagine the universe as a sheet of paper. If you draw a line from one corner to the other, that's the long way. But if you fold the paper and punch a hole through it, you create a shortcut. That's a wormhole, a tunnel connecting two distant points in space. Step in one side and instantly emerge somewhere else. Maybe across the galaxy, maybe even in another universe. Wormholes also come from Einstein's equations. They are mathematically possible. But once again, there's a problem. They are incredibly unstable. A wormhole would collapse almost instantly, unless it was held open by, again, negative energy. So once more, we run into the same barrier. Exotic energy we don't yet understand. But what if there are even stranger possibilities? Some particles, known as tachyons, have been theorized to move faster than light. If they exist, they would always travel faster than light, never slower. But there's no evidence they're real. And if they were, they could break the very structure of cause and effect. Messages could arrive before they're sent. Effects could happen before causes. Time itself would become unpredictable. And that brings us to the biggest problem with faster-than-light travel. It doesn't just challenge speed, it challenges time. According to relativity, if you could travel faster than light, you could, in theory, travel backward in time, and that creates paradoxes. The most famous one being this: what if you went back in time and prevented your own existence? If that happened, you wouldn't exist to go back in time in the first place. This is known as a causality paradox, and it's one of the main reasons physicists believe faster-than-light travel may never be possible. Because the universe seems to protect itself from these contradictions. But here's the fascinating part. We're still not completely sure. There are theories suggesting that time travel paradoxes might resolve themselves. That the universe could branch into different timelines, or that certain events are simply impossible to change. We don't have all the answers, and that's what makes this so exciting. Because every time we push the boundaries of physics, we discover something new, something deeper, something we didn't expect. So where does that leave us? Right now, faster-than-light travel remains in the realm of theory. Warp drives are possible on paper, but far beyond our technology. Wormholes might exist, but we don't know how to find or stabilize them. And breaking the speed of light directly still appears impossible. But not long ago, even reaching space seemed impossible. Flying across the world in hours was once a dream, and walking on the moon was science fiction. So the real question isn't just, is faster than light travel possible? It's this: how much of the universe are we still yet to understand? Because the deeper we explore, the more we realize. The rules of reality are far stranger than we ever imagined. And somewhere out there may be answers waiting. If you've made it this far, take a moment to like the video. It really helps more people discover these incredible ideas. And if you want to continue this journey into the unknown, make sure to subscribe, because in the next video, we're going to explore one of the most mysterious concepts in all of physics: wormholes. Do they actually exist? Could we ever travel through one? And what would happen if you did? Until then, keep looking up, because the universe isn't just bigger than we think. It's stranger than we can imagine.